right. So we've got a little bit less than 2 minutes left. Another reminder, you need to sign into your WVSU Google account before you join these meetings. Right now, it's okay. Like Carla, for example, you're obviously not signed into your Google account. I don't really care, but the reason I say that is because if I'm in lecture and talking, I might not notice that you're trying to log in. Like Carla, I had to manually let you in. Um, so make sure that you're logged into your Google account, your WVSU Google account. Again, I don't really care. It's just I want to make sure you're not like locked out of a class of a lecture. All right, it's almost 10. We'll get started here in a second. I will remind you, like I mentioned earlier today, today's points, the lab is still a 20-point lab, but your credit is going to be based on your attendance. So you've done step one, you're logged in, so that's good. And then so it'll be based on you being logged in and also you sending me the correct attendance words. So make sure you pay attention carefully. Um, Interesting. There might be an issue. Carla, we should look at that because you can see here like yours is it doesn't show it as that. But anyway, yeah. And then Carla, I wasn't like getting on to you or anything. I was just using that as an example. But anyway, so yeah, make sure you send those words. Make sure you send them within 5 minutes of the class, the lab ending. Again, like I was saying earlier, before some of you logged in, don't send the words to your friends. One of you here logged into the class at 8:37 today, yet somehow sent me all the attendance words. So being logged in isn't enough. Sending me the attendance words isn't enough. I kind of need both. And it's even more important for this because if you don't pay attention to what's happening today in this pre-lab lecture, then you'll be lost when we start, when we do the lab next week. So are there any questions about things in general before we get started into this discussion? All right. My goal is to get through this as quickly as possible because time is important. I don't want to waste your time. So let's jump into it. We got the slide. I've got a little PowerPoint presentation that we're gonna look at here. So let's jump into it. Again, this week, your grade, the full 20 points, is just based on you being here online and you sending me those words in time and you getting the words correct. So that being said, let's jump into it. Well, yeah, it's all right. This is stuff I've already said, right? So if you come in late or you leave early or you miss some of the words, right, you're only going to get partial credit. And I need you to send it within 10 minutes. I think I said 5 earlier, but yes, yeah, make sure you send those words within 10 minutes of us ending this lecture. Next week will just be a regular week as far as grades are concerned. You've got the pre-lab. Ooh, I'm so glad I said this. You've got the pre-lab, which is due Friday, as usual. But I need you guys to remind me, please. Some of you have already done the pre-lab, and I've already graded it. And if I remember off the top of my head, I forgot to give you the promised double points. So if you've already done the pre-lab and I didn't give you double the points, please remind me so I can give you the double the points. If you haven't done the pre-lab yet, that's okay. You won't get double the points. It'll just be like regular. Just make sure you send it in before Friday. And then as usual, you'll have 15 points for doing the lab itself. But where it gets a little bit different is you're going to need to write a lab report on this one lab. And that lab report is itself worth 20 points, which is the same as the lab report is worth the same amount as a single lab, right? It's worth 20 points. So before we move on, let's do the first word for attendance. How many points is your lab report worth? That's your first word for attendance, is to tell me how many points your lab report is worth. All right, let's move on. Like I said, I want to kind of get through this, not quickly necessarily, but I want to waste a lot of your time. So there's going to be 1, 2, 3, 4, 5 different experiments done next week. As usual, I'm going to break you up in teams and you're going to be doing one of them. But these are the questions that we're going to be answering in these 5 different experiments. The first one is, do photosynthetic organisms photosynthesize faster as you increase the light intensity, right? That's the first question. The second one is, do photosynthetic organisms respire when light is absent, right? Not photosynthesize, but respire. Do they do respiration when there's no light? The next one is, do photosynthetic organisms respire faster at warmer temperatures, right? So we're going to see if there's an effect of, if does temperature affect the rate of respiration. Then we're going to see if temperature affects the rate of photosynthesis. And then finally, we're going to see if the color of light affects the rate of photosynthesis. So then that brings up the question, like, how are we going to answer these questions, right? That's what I'm going to teach you today. How are we going to figure these things out? Are there any questions about this slide? All right, then let's move forward. I heard a noise. Let me back out here. I'll make sure someone's not like raising a hand or typing a question. Okay, yes. Question?
Can't see what you're sharing.
We can't see the power slide.
Oh, thank you. Thank you. So glad you said that. That would be helpful, huh? All right. There we go. And can someone confirm that you can see it now?
It's good.
Thank you very much, and I apologize. Okay. So yeah, that's again, how are we going to measure, how these things affect the rate of photosynthesis and respiration? That's basically in a nutshell what all these experiments boil down to, right? Does this affect the rate of photosynthesis and or respiration? So how do we do it? Well, first of all, like we mentioned earlier, you need to understand the chemical equations, right? So photosynthesis uses water and carbon dioxide to produce glucose and oxygen. So let's see if anybody can answer this. This shouldn't be too hard. If we could somehow measure the rate of, like we were doing these experiments and we could somehow measure the rate of photosynthesis and oxygen, and oxygen was increasing, right? If we could somehow measure the amount of oxygen, and oxygen was increasing, does that mean photosynthesis was happening or respiration? If the oxygen was increasing, what does that mean? Photosynthesis is happening or respiration? And here's a hint. Photosynthesis produces oxygen. Respiration uses oxygen. So if oxygen was increasing, what does that mean? Which one's happening?
Photosynthesis.
Perfect. Thank you. Good job. Whoever said that, when you send your words in, feel free to remind me that you said that, so I can give you a little bit more extra credit. Yeah. We know, if we could somehow measure the levels of oxygen, we know if it's increasing, that photosynthesis is happening. We know if it's decreasing, that must mean that respiration is happening, right? Because it's using it. Same thing with glucose. If we could somehow measure the levels of glucose, if glucose is going up, that must mean photosynthesis is happening. If glucose is going down and being used, that must mean respiration is happening. So on and so forth. So that's the basics, right? With that in mind, there's something else I should tell you. Actually, I'll go ahead and say this first, going along with the same conversations we were having earlier. If the carbon dioxide levels were going down, we know that photosynthesis is happening, right? Because photosynthesis uses carbon dioxide. If the levels of carbon dioxide were going up, we would know that respiration is happening, right? Because respiration produces carbon dioxide. So with that out of the way, and let's focus on this carbon dioxide stuff here.
Can you explain that a little bit more?
Sure. Let me see if I can erase this and maybe clear things up a little bit. Maybe. No, maybe not. Come on. Erase all. Yeah, there we go. So we talked about a lot, but let's just focus on carbon dioxide. When photosynthesis is happening, it uses carbon dioxide. Does that make sense? Carbon dioxide is an ingredient for photosynthesis. Therefore, if you could measure the amount of carbon dioxide, right? If carbon dioxide is going down, the levels of carbon dioxide are going down, we know photosynthesis is happening because photosynthesis uses carbon dioxide, right? Meanwhile, respiration, as you can see in this equation, produces carbon dioxide. So we know if the levels of carbon dioxide are increasing, then that must mean respiration is happening. Does that make sense? You good there now?
Yeah.
Okay, very good. I'm glad you asked. Yeah. So with that being said, I can go ahead and tell you now that is what we're going to measure. We are measuring the levels of carbon dioxide. If they're going down, we know photosynthesis is happening. If they're going up, we know respiration is happening. So now that leads to the next question, like how do we measure the levels of carbon dioxide? There's different ways, and I'm going to teach you one of the ways, the way we're going to do it. And before I can do that, I have to give you a little bit of background information, and you'll need to use this, you'll need to write about this in your lab report. So it just so happens that when you mix carbon dioxide and water, you get something called carbonic acid. You definitely don't need, I mean, when you write your lab report, you will need to talk about carbonic acid. But honestly, what's most important is that you understand we are creating an acid. So when you mix carbon dioxide and water, you are creating an acid. Therefore, we know, right, if respiration is happening, you're creating carbon dioxide, right? And that's mixing with the water that you also happen to be creating. Therefore, if respiration is happening, you are creating this acid, right? And therefore, well, I should have put those in different orders. Whoop, excuse me. Therefore, well, I say it like that, sure. When photosynthesis is happening and you're using carbon dioxide, right, and you're taking carbon dioxide out of the water, that means you're reducing the amount of acid in it, right? There's less acid when photosynthesis is happening because you're taking away the carbon. Therefore, you're taking away the carbonic acid. Therefore, the pH will increase. And that's the most important part for understanding what's happening in these labs next week. When pH goes up, that means photosynthesis is happening, right? Because pH or photosynthesis is taking that carbon out of the water, right? And therefore, we have less acid. And remember, as you learned in the other lab, an increase in pH means it's less acidic, right? So that's how we know photosynthesis is happening. Likewise, when respiration is happening, again, as we see here, respiration produces carbon dioxide. Therefore, we're going to have more carbon dioxide in the water. Therefore, we're going to produce more of this acid. Therefore, the pH is going to go down. Now, I want you guys to definitely understand everything I just taught you. But if you don't remember anything else, it's these bullet points right here. Because without understanding this, you don't understand your results. When photosynthesis is happening, pH goes up. When respiration is happening, pH goes down. And again, I gave you all the background information so you understand why that is the case. But even if you forget that, you'll still at least understand the results of your experiment. If you remember that when pH goes up, photosynthesis is happening. And if pH goes down, respiration is happening. So that brings us to the next word for attendance. When you're doing these experiments, if the pH goes up, what is happening? Photosynthesis or respiration? And I'll repeat that. When you're doing these experiments, when the pH goes up, what is happening? Photosynthesis or respiration? So any questions about this slide before we move on? Okay. So what's going to happen is, again, now that you know, we're looking at pH, right? We're going to use pH as our tool to measure the rate of photosynthesis and respiration. So what you're going to do is you're going to have these cuvettes, which actually don't look exactly like this. They're more square shaped and all that, but not that it matters. But these are what we call cuvettes. They are filled with these little algae beads, and they are filled with water, and they are filled with another liquid called pH indicator that we've also used in lab 2. So you're familiar with this. As the pH changes, so does the color. And you also get these little strips like you used in lab 2, right? So you're familiar with this, and you're going to compare it. So every 5 minutes, whichever experiment you're going to do, you're going to take one of these cuvettes and you can compare it to this strip right here, and you're going to determine what the pH is, and then you're going to write it over here, and you're going to do that for 45 minutes. Does that make sense, right? Anybody have any questions? That's pretty straightforward. You're going to see how the pH changes every 5 minutes in whatever conditions you do, and you're going to write that down in your table. So let's really quickly readdress readdress each one of the questions, each one of the experiments, and see what we should expect to happen in this situation, right? So the first one we're going to answer, the first question is, do photosynthetic organisms photosynthesize faster in more intense light? So you're going to have 5 cuvettes. You're going to have one that's in the complete dark, and that's kind of like your control. So we are expecting, since it's in the dark, we are expecting it to only do respiration and not photosynthesis. So therefore, we would expect the pH to go down, right? Because it is producing carbon dioxide. Therefore, we expect it to go down. Then we're going to have one very close. We're going to have one close to a light. We're going to have one even closer to the light. And we're going to have one the closest to the light, right? And again, we expect all 3 of those we would expect to increase, right? Because it should be photosynthesizing. Therefore, the pH should go up. The question is, which one will increase the most, right? Is it the one that's going to be closest to the light, the one farthest away from the light, or the one in the middle, right? And we're going to see which one happens. And that's up to you to make your hypothesis, which one you think is going to happen. Now, I will say this to help you form your hypothesis. Obviously, common sense tells us that the more light you have, the more photosynthesis you would have. But keep in mind, everything, there's a limit, right? There is a limit to that, right? So at a certain point, there's only so much light, right? These enzymes that are doing all these chemical reactions, they can only work so fast. So there is a point where it's just photosynthesis is not going to happen any faster, despite how much light you put on it. Now, granted, I don't know if that'll happen in these experiments. We might not hit that point, but that's just something to keep in mind. So any questions about that first experiment? Okay. The second experiment. This one's a lot simpler. We have 1 cuvette in the light, 1 cuvette in the dark. This one's just asking the question, do photosynthetic organisms still do respiration even though they're in the dark? Now, granted, we're talking about respiration here. Respiration, not photosynthesis. So again, the one in the light, we would expect it to go up because it's in the light, it's photosynthesizing, it's reducing the carbonic acid, right? The one in the dark, we expect it should go down, right? Because if it's doing respiration, then it's producing carbon dioxide, which is increasing the acidity, right? But the one thing I want you to keep in mind for the experiment, because that does seem straightforward, right? Like, yes, when it's in the dark, it will respire, right? Respiration has nothing to do directly with light. But keep in mind, this is sort of like what I said earlier, these are all chemical reactions that are happening. So yeah, it might be in the dark. It might be using that glucose to do respiration. But at some point, it's feasible that it might run out of glucose, right? And where does the glucose come from? It comes from photosynthesis, right? So if it's in the dark, it's not doing photosynthesis. It's just using the glucose that it has. So at some point, it could straight up run out of glucose. Will that happen during this experiment? I don't know, but that's just some things to keep in mind. So any questions about that experiment? All right, the next experiment. This one, we're going to see how temperature affects the rate of respiration. So this is another respiration one. So we're going to have, again, in my opinion, this is fairly simple. You're going to have 2 cuvettes, both of which are going to be in the dark. And by the way, just so you know, when I say in the dark, they're going to be wrapped in aluminum foil. That's how we're going to keep them dark. One of them is going to be in an ice bath. One of them is going to be at room temperature. And we're going to measure, measure the pH. And again, for both of them, since they're both in the dark, we are expecting the pH to go down because that means, it's not in the light. It's in the dark. So it's doing respiration, right? It should be anyway. And it's going to be using the glucose to produce carbon dioxide, right? The more carbon dioxide there is, the more it'll go down. And the thing I would say that you should keep in mind, so obviously, again, we should expect both to go down. So there's some things to keep in mind, like which one's going to do best, room temperature or ice. There are a few things to consider. For example, as we learned earlier, when you learned about enzymes, temperature does affect enzymes. There is an optimal range. So there is a point too, like I said earlier, if it gets too warm, it'll be outside of its optimal range, right? Also, if it gets too cold, it'll be outside of its optimal range. If it gets too hot, which I doubt will happen, that would just denature the enzymes and it wouldn't work at all, right? So that's one thing to consider. Another thing to consider is something else we talked about in lecture, which is that generally speaking, the more heat you add, because remember, heat is molecules moving. The more heat you add, generally speaking, the faster a chemical reaction should happen. So we should, in some ways, expect photosynthesis to do better. Respiration to do better in the warm, in the room temperature, right? Because it's faster moving molecules. Maybe it's the optimal range. I don't know what the optimal range of these enzymes are because I don't know where this algae is from, right? If it's algae that lives on the bottom of an ice cube or of an iceberg in the Arctic Ocean, its probably optimal range is probably very cold. If it's algae that comes from a tropical pond, we would probably expect its optimal range to be pretty warm. And we don't know that. So we're just kind of taking a shot in the dark. But we do know, again, that generally speaking, the warmer things are, the faster the molecules are moving. Therefore, generally speaking, the faster chemical reactions are happening. So any questions about that experiment? All right, the next experiment, same thing, except we're looking at photosynthesis, right? So you'll have one, they'll both be in the dark. You're going to have one at room temperature, one on ice. Again, we're expecting both of them to increase because it's photosynthesis. Therefore, it's using carbon dioxide, which is going to lower the amount of acid, which will increase the pH. That one's pretty straightforward. And everything I just said previously about the respiration one, same stuff, right? Optimal temperature. As the temperature increases, you generally expect an increase in rates of chemical reactions. So same concepts, except now we're looking at photosynthesis instead of respiration. Any questions about that experiment? We're making good time. All right. So this is the last of the experiment. In this one, we're going to look and see how different colors of light affect the rate of photosynthesis, if at all. And in this case, you're going to have 4 cuvettes. One's going to be in a white light, one's going to be in a green light, one's going to be in a red light, one's going to be in a blue light. Some things that you should know about this before, and you'll learn this in lecture before we have the experiment next week, but I'll just go ahead and give you the basics right now. White light is all the lights. So white light includes green light, it includes red light, it includes blue light, orange light, all the lights not listed, all the colors not listed, it's all included in white light. So white light includes all the lights. Another thing to know, red light is the lowest energy of all the lights. So it does not give that much energy. Like conversely, blue light is the highest energy of all the lights. And then finally, green light, I can go ahead and tell you this, and you're going to learn more about this in lecture. The reason plants look green is because white light is hitting the plants, right? And white light is all the colors. And the plant is then absorbing all the different colors other than green. The color green is reflected back. And that's why they look like they're green to us, because they've absorbed all the other colors. And the only one that's bouncing off of them, the only color they are not absorbing is green. And that's why the green color is hitting our eyeballs and our brain says that thing is green. So keep that in mind. That's a big hint because, we're going to look what color is the best for photosynthesis, what color is the worst for photosynthesis. So, there's a lot of things to consider, right? Is it the one with all the lights? Is it the one with the highest energy light, lowest energy light, the one color light that's not being absorbed, so on and so forth. So are there any questions about this slide? All right, the next word for attendance. Of all these colored lights, white, green, red, and blue, which one has the highest energy? And granted, that one's a little bit more difficult than the other ones because I said it. I didn't, it's not written down there on the slide, but I did say which one was the highest energy. So that's your next word for attendance. It's the multiple choice question. White, green, red, or blue. Which one is the highest energy? All right, if there's no questions, we will move on to the next slide. And again, that's all the experiments. We've just talked basically about how all the experiments are going to go. And again, I just want to point this out. This is a pre-lab question too, which is why if you've already done the pre-lab, you're going to get double the points because you had to answer this before I taught it. and the rest of you will just get the regular points because I'm about to teach it to you. The purpose of these experiments is not to see how the pH changes. This is not a pH experiment. pH is just a tool. We are using pH to measure photosynthesis and respiration. This will be very important when you're writing your lab report, right? So we're not focused on pH. It's just a tool, right? It's just a tool so we can measure the rate of photosynthesis and respiration. Just like any other, like this right here. We talked about this when we first started. If we could somehow measure the amounts of oxygen, then that's another way we could measure the rate of photosynthesis, right? If oxygen's increasing, photosynthesis is happening. If oxygen is decreasing, respiration is happening, right? This is just a tool. pH is not the focus of this experiment. It is just the tool that we are using. Now, granted, you need to be very aware of how your tool works, which is what we talked about, but I just wanted to point that out. So, are there any questions about this slide? All right. Some other things, I've already kind of said this, just so you know, if we have a cuvette in the dark, that means it should be doing respiration, which means it should be producing that carbon dioxide, which produces the acid, which means the pH should go up. We should expect that. We should also expect all the ones in the light should be going. Oh, what? Sorry, I said that wrong. Man, I'm so sorry. I'm distracted because I'm working from home. No cuvettes in the dark should increase, right? If it's in the dark, it should be respiring, right? So if it's in the dark, the pH should be going down. They should not be going up. If it's going up, that means respiration is happening or some carbon dioxide is coming from somewhere, right? So we expect if it's in the dark, it should not go up, right? Meanwhile, if it's in the light, it should not go down, right? So if any of your results have a dark one going up or a light one going down, we can say there must be some sort of problem, right? Therefore, your results are invalid, which won't hurt your grade. But when you do your lab report, you'll need to write about that. Here's the results, but they don't prove anything. They don't, my results are useless because of that. And we'll talk more about that when and if that happens in your experiment. If that happens, you can raise your hand, and we'll come over there and talk about what that probably means. But generally speaking, if this happens, there must have been something wrong. Either you're reading it wrong, or whoever put these cuvettes together for you put something in wrong, or maybe some of the algae are dead. I don't know. There's so many things that could be wrong. But the point is, if we see something unexpected, we can assume that there's something wrong with the setup or the way you're doing it. And therefore your results are invalid. And again, just keep that in mind. So raise your hand if in these experiments you get these kind of results so we can talk about it, because that will be important for your lab report. Any questions about that slide? Okay. Some other things, some random notes. While you're doing these experiments, you should be doing these for all the experiments that we do in this course, but even more so for this one, because you're going to have to write about this in your lab report. Think about how these experiments can be performed in a better manner. So when you're looking at, as you're doing them, like, hey, man, this isn't really an issue that we're doing it this way. It would be better if we could do it that way. Sort of like, remember when we did our very first lab and we were measuring everybody's height and we talked about all the things that we could do better. Like, it would be better if everybody was barefooted. It'd be better if everybody was bald-headed. It'd be better if we had a real thing to measure people instead of some tall guy holding two rulers against the wall, right? So that's what you're going to need to think about as you're doing these experiments, because when you do the lab report, you're going to need to write about them. And also pay attention, because during the experiments, I will be talking about that, as I always do, right? So make sure, when I'm talking, if you can, as long as you're not busy doing something, try to pay attention to what I'm saying, because I'm basically going to be telling you what you need to be writing about. Also, you'll have to write a little bit about this. Think about a different experiment, right? So in this experiment, you were using pH, the change in pH, to measure the rate of photosynthesis and respiration. So just use your imagination, and whichever one experiment that you're doing, think about how else you could do it. And I'll give you one example, but now you can't use it. The most easy way to do this, right? So let's say you're doing the one about different colors. You could take a group of plants, plant some of them in white light, some of them in blue light, some of them in green light, some of them in red light, grow them for, 6 months, And maybe every week you measure how tall they are. That's right. And then that's how you'd be measuring photosynthesis. In that case, you'd be measuring the height, right? The more it photosynthesizes, the faster it grows. And that's another experiment you could do to test your hypothesis for that, that last experiment. So I've used that example. Now you can't use that example, but yeah, so just think about that. Use your imagination. Any questions about this slide? All right, let's move to the next one. Now, because that's it for the experiments. Now we're going to talk about how to write a lab report. I guess actually really quickly before I talk about that, I just want to show you Lab 6 Prelab, so no one messes this up. Let's look carefully here. You, as usual, you have a video to watch, right? A video and some questions. Then a second set of videos with questions. Also hint, just so you guys know, this will help my life and help your grade. You are in 101-02. That is your section number. 101, your course and section number, 101-02. Please use the correct section number. Then when you're done with that, there's this video that you can watch, but you don't have to. Then, and you can click this, and this gives you the introduction that you should read. And then you can use the information in that introduction, as usual, to answer the pre-lab questions. So your answers to this pre-lab questions are going to come from this introduction. But I put it in a separate document just so this document can be less cluttered. Any questions about that? It's the same as usual. You have the introduction that you need to read first, except now I just kind of put it in a separate document just to make things, again, less cluttered. Now, another thing you need to know, there's a virtual lab you can do. One of your classmates has already done it. It's the same concepts. It's just testing. It's just finding a different way to measure the rate of photosynthesis and respiration, and it's all virtual. It's a lot of work, but if you do it, you can get if you do it before this lab, you can get up to 20 points of extra credit. If you do it after this lab, you can get up to 10 points of extra credit. And the reason I want you to do it before this lab, before you physically come in next week, is it'll really help your brain get into that idea of how photosynthesis and respiration works, and this idea of using different ways of testing, measuring the rate of photosynthesis and respiration. Anyway, so again, you have 2 videos to watch. You need to read the introduction, answer these questions, and then, as it says right here, as a reminder, you have 5 sets of hypotheses, right? So, and look, and they're in red, right? So you answer your first hypothesis. Scroll down to the second experiment, answer your second hypothesis. Scroll down to the next experiment, answer your next hypothesis. Scroll down to the next experiment, answer the next hypothesis, and finally scroll down to the last hypothesis and answer the last set of your last hypothesis question. Another thing, and I love that some of you guys are trying, and maybe you guys didn't remember what we talked about in the first lab, but a prediction is an if-then statement that describes how you're going to test your hypothesis. So if you say, I hypothesize that photosynthetic organisms do not respire when light is absent, then your prediction, using this experimental design, you would say, if I put a cuvette of algae bead and pH indicator in the light and one in the dark, and measure the rate of change of pH, then I will find the one in the light is increasing, or whatever, as long as your prediction matches your hypothesis, and it's an if-then statement that describes how you're going to test your hypothesis. So any questions about your pre-lab that is due this Friday? Again, video questions, pre-lab questions, hypotheses. And as always, you don't have to do it alone. Meet me online. I can walk you through all of it. That being said, now let's jump back into this and talk about how to write a lab report. Before I do that, I want to show you this. This is where you're going to find it, your lab report. You can click on that on My Online. It'll bring you to this page. You're going to click on this, and it'll bring up this sheet. This is sort of like a lab, right? You're going to click on it like usual, like you would a lab. You get this Google Doc. It's not your Google Doc. You have to make yourself a copy as usual. And then you're going to use this sheet to write your lab report, right? So here's the grading rubric, which I'm about to talk about here in a second. That's your grading rubric. And then down here is where you'll write your lab report, right? You're going to keep this up here because this is what I'm going to use to grade your lab report. So this is the sheet you're going to use. You're not going to change anything above this line. You're going to leave all that as is up there, and you're going to write your lab report starting here, working your way down. Are there any questions about that? All right. Now let's jump into it, and hopefully I can get you guys out of here soon. We're making good time, I think, so far. How to write a lab report. Here we go. The first question you might be asking yourself, why? not just how, but why? Why do I even have to write a lab report? It's a 100 level class. I'm not a biology major. What's the purpose? So the first thing you need to understand, my first answer is it's part of the course. And it's not my call. Somebody way above my pay grade said, hey, this is a science course, and it has a lab component, and the lab component in the science course should be required to write at least one lab report. Someone told me that. That's what we're doing. The second part is, you have to truly understand the experiments you did to be able to write a lab report, which is why in a perfect world, I would have you guys, instead of doing lab worksheets like you guys do, I would just have you do the experiments, collect your data however you want and write a lab report about it. But it's a 100 level class for non-biology majors, so I wouldn't have you do it. That's way too much work. But yeah, in a perfect world, that's what I would have you do, because it's hard to write a lab report if you don't understand what's happening. And then finally, and this is a little bit more relevant to your everyday life, by writing a lab report and being familiar with the process of writing a lab report, you are then a little bit more equipped to understand research articles. And you guys might not be reading research articles now, but I hope one day in your life you are. I hope when someone presents you with information as a college-educated citizen, you don't just believe them. You do your research, right? You start reading what other research other people have done. So this all helps, right? This is why we do this. So here's some information, some things you need to know. Do not use the internet. And I'll come back to that, right? So what I mean by that is I'm about to teach you how to write a lab report. So what you don't want to do when it comes time to sit down and write your lab report, do not Google, how do I write a lab report? The reason being is because there's different ways to write a lab report. Just like those articles I was just talking about in that last slide, there's different peer-reviewed articles, and each journal has a different way that they want it done. And the way I'm about to teach you, that's the way I want it done. So do not use the internet to see how do you write a lab report. Use this information that is in this slide, and it's on that worksheet I showed you previously. That's your guideline on how to write a lab report. Do not use the internet. I should say 5. There's 5 experiments being done. You are only doing one of them. Therefore, you only have to write about one of them. Now, if you want to write about the other ones for extra credit, by all means, do that. But do that separately. If you want to do that, let me know. We'll just talk about it. Just know you're only writing about the experiment that you did. Another thing, make sure it's first person and past tense. So you'll say, the first thing I did was put a cuvette 10 centimeters from the light source. And then I put another cuvette 15 centimeters from, right? It's first person, so it's me, my, whatever, and past tense. Now, granted, you're not going to lose many points if you screw that up, but yes, first person past tense. So not we, but me. You're going to want to make sure it's double spaced. A lot of you, I've said that for independent work too. A lot of you aren't doing that for independent work. No one lost any points for that for independent work, but you will lose a minimal amount of points if you do that for the lab report. It needs to be double spaced. I always get this question. Is there a minimum? How long does it have to be? There is no minimum. Short and sweet is what I say. And you'll see when I show you the rubric, you want to make sure you can check all the things off the rubric, but you don't need to make it long, right? So you don't need to use adjectives. Like you don't say, the first thing I did was took the small cuvette in between my fingers and I gingerly put it on the table 10 centimeters from the light source, which was a lamp painted black, right? You don't need a bunch of extra words. Length is not the purpose here. This is not an independent work paper. Even then, I don't want you writing a bunch of useless garbage. But yeah, so there is no minimum. You're going to turn it in the same way you would independent work. You're going to turn it in. Actually, no, I need to update this. Sorry, this is old. You're going to turn this in the same way that you would labs, right? You're going to open that worksheet. You're going to go scroll below the rubric. You're going to write it there. You're going to save it as a PDF, and then you're going to upload it to my state or my online. And again, if you need help with that, let me know. The due date is 2 weeks after the lab. So 2 weeks from Wednesday is the due date. However, you can start it. As you see, once I start talking about how to write a lab report, there's a lot of this stuff you can write even before doing the experiment, because some of it, well, you'll see. So yeah, any questions so far? All right. The next word for attendance. This is yes or no. When you are ready to write your lab report, should you use the internet to look up how to write a lab report? Yes or no? All right. That being said, let's move forward. Yeah, this is a continuation. As you might expect, it should be free of grammatical, spelling, or typing errors. Double check yourself. And I'm really not that picky. Unless it's really horrible grammar. I seen that the pH changed instead of I saw. Just things like that. I'm not that picky. You might look into running it through a spell checker, a grammar checker, or something like that, just to make sure. But yeah, you'll lose points for errors, depending on how many errors you make. It should make sense. That's going to be a big thing. As I read it, you're going to lose a lot of points if I have no idea what you're trying to say. And again, if you want to have somebody else proofread it for you and say, hey, does this make sense? And you might be thinking, well, what do they know? They're not taking the class. But that's kind of the point. You should have enough information in your lab report where someone who's not taking the class or was never in that lab should understand what you were saying. Like, oh, yeah, that makes sense. It should be accurate or correct. That's obvious, right? So, for example, if one of your cuvettes saw an increase in pH, but then you went on to say it decreased in pH, obviously you're going to lose points, right? That's not accurate. That's not correct. It should be precise. Cross that bridge when we get there. That's actually not as important, in my opinion, for this 100 level class. And again, we'll cross that bridge when we get there. It should be succinct. I already mentioned that earlier. This is not supposed to be wordy. You don't want to use about a bunch of adjectives. You're not trying to make this an entertaining paper. Just get to the point. And again, these kind of go together. It should be clear that you understood the experiment. So these two things kind of go together. And if I can't understand what you're saying, then obviously you didn't understand the experiment. Or, sometimes, again, some people make mistakes. Like their data shows that photosynthesis happened, but then when they write about their data, they say photosynthesis did not happen, right? That clearly you didn't understand the experiment in that example. Anyway, any questions about that slide? All right. Moving forward. All right. So again, I showed you briefly that there's that rubric. That's what you're going to use to write your lab report. Here's the bottom line. If there's one thing you forget about everything else I'm saying about how to write a lab report, it's this. Just read the rubric. If you have to, go line for line, and it'll tell you exactly what you need to do. Like, number one, is there a title? Oh, first thing I better do is come up with a title. Number two, is the title appropriate for the experiment? Oh, yeah, I guess I should fix that title and make sure it's appropriate. Number three, is the abstract section labeled? Oh, I guess my next step is to make an abstract section and label it the word abstract, right? If you forget everything else I'm telling you today about how to write a lab report, remember this. Just use the grading rubric. Go line for line, and you can't go wrong. Your lab report is going to be broken down in the following sections, and we're going to talk about them separately and quickly, I hope. You're going to have your title, followed by your abstract, followed by your introduction, followed by materials and methods. You can read it right there. I'm not going to waste my time reading all of them because we're about to talk all about all of them separately. Again, your class will be performing 5 experiments, but you are only doing one. That's the one you're going to be writing about. Therefore, your title should indicate which experiment you did. So a bad title would be Photosynthesis Respiration Lab. Like, that's not a good title. Tell me which experiment you did. Likewise, if you're going to tell me which experiment you did, tell me which experiment you did. not another one, right? So if you did the first experiment that's all about light intensity, then a really bad name, a really bad title for your lab report would be how different colored lights affects photosynthesis, right? Because that's not the one you did. You didn't do different colored lights. You did different light intensity. So any questions about the title? Okay. This brings us to the abstract. That's your next section. This is a brief summary about what your paper's about. All right. It's going to be labeled. So again, you'll have the word abstract, and then under that, you'll have a paragraph that you write, which will be your abstract. It should let the reader know if they want to read the rest of the paper. So in this case, that's what a real abstract is for. So for example, if you're doing research on the internet and you're like, hey, I'm wondering how, I don't know, how climate affects the rate of tuberculosis. And then you're going to, look at all these different peer-reviewed articles, and you're not going to read each one of the articles. You're only going to read the abstract and see, like, oh yeah, that's exactly what I'm looking for. And sometimes you don't even need to read the rest of the article, because the abstract will say, look, this is basically what we did, and here's basically what we found out. And sometimes that's all you need. So for you, when you write this lab report, that's the information that needs to be in your abstract. It's not a detailed description of what you did. It's not a detailed description of your results. It's just a basic description. So like you could say, if you did the first experiment, and this experiment, I wanted to see, or I was trying to find out if light intensity affected the rate of photosynthesis. I used changing pH. I used algae beads filled with water and a pH indicator, and I tracked or measured the rate of change in pH, and I found out that yes, it does affect the rate of photosynthesis, whatever it is. It's just the basics, right? You don't need to go into detail. That comes later. It's just the basics. So any questions about the abstract? All right. Next comes the introduction. And in some ways, the introduction is a lot like the abstract. Some of it does overlap, except now that here's basically what you need to know about the introduction. Anybody should, after they read the introduction, then everything else should make sense, right? Because later when you talk about how you did it, and you're talking about, the pH did this, the pH did that, that would make no sense by itself. But after the reader has read the introduction, they'll understand what that means. Because again, these experiments are not about pH. So when they're reading this change, the pH change this way and that way, that would make no sense. But first they've read the introduction, and you're going to explain what the change in pH means, right? So the introduction gives enough background information that the reader can understand the rest of the experiment. As always, as with all the cases, it should be labeled. So you'll have the word introduction, and then under that, you'll start writing your introduction. You'll need to give a basic background information about photosynthesis and respiration. So that somebody reading your lab report can understand the rest of it. So at the very least, no matter what experiment you're talking about or you do, you should definitely talk about the fact that photosynthesis uses carbon dioxide, and respiration produces carbon dioxide. Because again, later in the introduction, you're going to explain the pH thing, right? So at the very least, no matter what experiment you do, you're going to need to talk about that. Then there's some other things, right? If your experiment is about light intensity, you might want write a couple sentences about how light affects photosynthesis. If yours is about respiration, you should have a couple sentences about respiration. If yours is about different colors of light, write a few sentences about, like, basically what I was saying earlier about how, green light is the only one that's not absorbed. White light is all the colors. Red light is the lowest energy light. Blue light is the highest energy light, right? You'll give the reader background information so that they understand the idea of your experiment, like why, the basics. Obviously, and I shouldn't say obviously, even though you already mentioned it in the abstract, you're going to say it again. You're going to include the question that you're answering in this experiment. In this experiment, I wanted to see how light intensity affected the rate of photosynthesis, right? So you're going to repeat it. Then, after you've repeated your question, then finally, for the first time, you're going to tell us what your hypothesis is. I hypothesize that yes, light intensity will affect the rate of photosynthesis because, right? And then you explain why. So you guys with me so far? Any questions? All right. If somebody raised their hand or did something, you could just turn yourself off of mute and go ahead and ask your question.
So the difference between the introduction and the abstract is just the introduction has those extra steps, which is like the hypothesis and the other questions as well, or how is it different from the abstract?
Yes, yeah, and you'll see as I still have more to say about the introduction, but yeah, the abstract is like, all right, here's basically what we did without going into detail, and here's basically what we found, and here's our basic results, right? So the abstract is just like, I was trying to answer this question, I did it in this way, and here was the answer to that question. But here in the introduction, you're giving people the information, the background information. Like, what is it? How does light, depending on the experiment you're writing about, how does light affect photosynthesis? How does the light color affect photosynthesis? If you're doing the ones about temperatures, right, you would write something about how temperature affects enzymes and how temperature affects the rate of chemical reactions. Yeah. So then again, abstract is just, here's what we wanted. Here's the question. Here's what we did to answer the question. Here's the answer to the question, right? Just the basics. Introduction, again, you go into more detail. So after you write your did that answer your question?
Yeah. Thank you.
Good. So then when you're done writing what your hypothesis is and explaining why you think what you think, then you need to basically write down what I told you earlier about the pH, right? You're going to talk about how photosynthesis I would talk about respiration first, right? Respiration produces carbon dioxide. When carbon dioxide mixes with water, it produces an acid. Therefore, when respiration is happening, pH goes down. Conversely, photosynthesis uses carbon dioxide. Therefore, there's less acid in the water. Therefore, the pH goes up, right? You need to explain that because, again, later in the lab report, you're going to say, this is what happened to the pH. But you don't need to explain what it means. You don't need to explain, you just need to say the pH did this, the pH did that. And because the person read the introduction, that part will make sense. Any questions about that bullet point? All right. There's a lot of things that shouldn't include, and this is all on the rubric. So again, this is just the introduction. So you don't want to specifically talk about exactly what you did for the experiment. Like I used this many cuvettes and I measured them for 45 minutes and every 5 minutes I took the pH, right? That comes later. You don't want to do that. Another thing is, unlike the abstract, going back to, I think that was Lebdy. I think that was his question. You don't want to talk about your results in the introduction. You do in the abstract, but the introduction, you don't. You're just giving them, again, just enough background information to understand what you're about to write in the other sections. So any questions about the introduction? Moving right along. Next comes the thing I just talked about. That's materials and methods. Here, you are going to explain how you did your experiment. And it should include everything that you used, right? So long story short, the biggest thing you should remember for this section is somebody should be able to take your materials and methods section and be able to use that information to do the same exact experiment you did. There should be enough information where they could do the same exact experiment. So again, it should include everything that you used. Like, for example, a lot of people somehow forget to mention the fact that there's algae beads inside of those little cuvettes. Like, so what, you got cuvettes and we don't know what's in them? What in the world does that have to do with photosynthesis? Or they won't mention the fact that there's a color guide. So yeah, we measured every 5 minutes. We looked to see what the pH was. Okay, well, how did you do that, right? You need to describe, we compared the color of the cuvette to the pH color guide to figure out what the pH was, just as an example. So yeah, not only should it include everything that you used, but again, it should include everything that you do, right? Again, somebody should be able to read what you did and be able to recreate the experiment. What you don't want to do is go to the Lab 6 worksheet and copy and paste what they have, right? Because again, this is going to be first person past tense. So don't do that. Write what you did, you narrate what you did. Another thing, these are your experiments, right? So you might call an audible. You might change things up a little bit if you want. And if you're allowed to do that, you might want to ask me first. But if you make some changes to what you did, then you need to write about what you did, not what the lab not what the lab instructions tell you to do. And I'll give you this one example. Most likely, not to muddy the waters, but most likely you guys will end up, instead of taking pH every 5 minutes, if you're doing a respiration experiment, you might take the pH every 15 minutes, because let's be honest, every time you open it up and take it out of the aluminum foil to see what color it is, you're exposing it to light, right? So that's a big flaw in the experiment. So again, if you happen to do that and you check the pH every 15 minutes, then that's what you need to write about. You don't say I check the pH every 5 minutes. You say I wrote it every 15 minutes. And then one more example, the first experiment where you have 4 cuvettes, one's in the dark, one's close to the light, one's closer to the light, one's closest to the light. If we have extra cuvettes, you might be able to do more than that. Have one even closer to the light, and you might be able to do that for extra credit. And if you do that, again, if you make a change to the materials or the methods, that's okay. Just make sure you write about what you did, not what the lab instructions told you to do. Any questions about that concept? All right, moving forward. Again, this should not explain why you were why you're doing, so you can just say, every 5 minutes we looked at the liquid in the cuvette and compared it to the pH color guide and recorded the pH, right? But you don't need to say why you did that. When we did that, because if the pH is increasing, that means photosynthesis is happening, right? You don't need to do that. You already took care of that in the introduction. So any questions about that concept? All right. That's it for materials and methods. Let's talk about results. And this might be a little tricky, so pay attention. And I'll go ahead and say this too before I talk about results. I've written the labs that you've done so far to condition you and train you for these next 2 sections. You'll notice that there's a pattern. Very often in a lab, you'll have a table with your data in it. And then there's a question where you just repeat the data. You put it in words. And then there's a question after that where you explain what those words mean, right? So you explain if your hypothesis was correct or not. So that being said, let's talk about it. Results. This section simply puts data into words. Again, you don't want to put the figures in tables, right? You'll have that somewhere else, but you're going to take that information that you have in your table and you're just going to put it in words. That's it, right? So it's not going to be in a form or in a table. It's going to be in a paragraph form. At the very least, you should include the starting and ending pH of all the cuvettes, right? So the one in the dark started here, ended here. The one closest to the light started here, ended there. The one farthest from the light started here, ended there, so on and so forth. Even though it's in the table, you're putting it into words in a paragraph form. Sometimes it's going to be relevant to talk about not just which one started here, ended here, but you'll need to talk about the superlatives, right? So, by the way, the one in the dark, it decreased the least, or the one in the light, it increased the most, or even the fastest. And really quickly, to give you an example, you might have a pH like you've got 2 cuvettes. Both pHs start at 5, and then after 45 minutes, they end at 10, right? In that case, you're definitely going to need to talk about which did the quickest, because they both increased the same amount. So then you're going to need to look at all this in-between data and see which one got to 10 first. So again, definitely include the starting and ending pH, and then you'll talk about the other relevant stuff, right? Which one increased the quickest or the slowest? Which one increased the most? Those are things you'll need. And when you're doing your labs, obviously I'll be there to help you, and I can look at your data and be like, oh yeah, when you write your lab report, you're definitely going to want to talk about this. Anyway, any questions about that concept? Okay, next. Again, if applicable, if you've done the experiment and none of them changed, then you should definitely mention that, right? Hopefully that won't happen for any of you, but if it does happen, you should definitely include that. When you're writing about them, you should write about the condition that they're in, right? So you might be labeling your cuvette number 1, number 2, number 3. But when you're writing about it, you don't want to say cuvette number 2 did this, cuvette number 3 did that. No, you don't want to do that. Tell me what condition it was in, right? Like the cuvette closest to the light started here, ended here. The cuvette in the red light started here, ended here. The cuvette and the ice bath started here, ended here, right? Whatever experiment you're doing, when you're writing about them, you're going to describe them by their condition. Like what condition were they in? Any questions about that concept? Okay, moving forward. What you want to do, what you definitely don't want to do, and people mess this up a lot, and this is actually make things easier for you, but people still screw it up. The word photosynthesis and respiration should never come up in this section because you're just giving the data. You're not explaining what the data means. And the data is nothing but a change in pH, right? So later in the next section, you're going to explain what the data means and how increasing pH means the pH photosynthesis is happening and decreasing pH means respiration is happening. But for now, you're just putting into words the information that is in your table. So are there any questions about that concept? All right. That's it then. So results. Or excuse me, that's it for the results. Next comes the discussion. And again, you're already trained to do this from the labs that you've been doing all semester. I've been training you to do this. After you explain the result, after you give the results in paragraph form, like as a sentence or two, next you're going to discuss what it means, right? And this part is a little bit redundant, I will admit. So the discussion, you're going to kind of say the same stuff you said earlier, right? You're going to repeat the purpose of your experiment, right? We're trying to find out if light intensity affects the rate of respiration, right? You're going to repeat that. Then you're going to repeat your results again. So just like you had the results section, except now you're going to explain what it means, right? So you will say, like as I said in the results section, the cuvette closest to the light had the largest increase in pH. And that's all you said in the results. But then here you'll go on to say, and that means the cuvette closest to the light, photosynthesized at a greater rate than the rest of them, right? You'll explain what it means. And then once you've done that, like, here's the results again. Here's what it means. Therefore, and then you kind of restate your hypothesis, therefore my hypothesis was correct because, I thought my hypothesis was that it would affect the rate of respiration. And as you can see from the results, it did, right? So make sure you restate your hypothesis and you're just explaining not only what that change in pH means, but you just briefly explain if it supports your hypothesis or if it doesn't support your hypothesis. That's it. Try to avoid the word prove because you're not proving anything, right? Our sample size is too small. There's too many flaws in the experiment. You're not proving your hypothesis correct or incorrect. You're only supporting it or not supporting it. Any questions about that concept? All right. If your hypothesis was wrong, you might explain like a sentence, maybe explain a sentence of why you think it was wrong, right? So maybe there was something wrong with the lighting conditions, or maybe the person that you put in charge of looking at the color change was colorblind. I don't know why you would put them in charge of it, but something like that. Which brings us to the next bullet point. And again, you've been conditioned to do this too with all these labs. This is why I have so many questions in the labs. I'm conditioning you to do this. Address the limitations and the flaws of the experiment, right? So you see in a lot of the labs, they'll say, how could this lab be improved? Same thing here. And again, while we're doing the experiments, I'm going to be talking about them. Just like, for example, like I was doing the first experiment where I was talking about like the flaws of how I was measuring my height and how people are measuring their finger spans, right? Same thing. While we're in class, while we're in the lab, as I'm talking, as long as you're not busy with something, you should pay attention because I'm going to be giving you all this information and we're going to be talking about it, right? So you need to talk about all the flaws in the experiment, how the experiment could be better. And for one example, you're only doing it for 45 minutes. And if you look at your data, depending on the situation, if the data seems like it keeps moving and you just stopped it short at 45 minutes, then that's, you can say, hey, yeah, well, obviously things were still happening. So it would have been better if we kept the experiment going, things like that. So any questions about that? All right. And again, like I said, I've been kind of conditioning you for this, for some of them. You're going to talk about, and as I mentioned earlier today, you're going to discuss other experiments that you can perform to test your hypothesis, right? So use your imagination. What are some other ways you could see if photosynthesis affects light intensity affects photosynthesis, or if temperature affects respiration, or if light color affects photosynthesis, whatever it is, right? Come up with some other basic experiment, write a basic experiment design, because that's how real science works. To remind you from chapter 1, right? You don't just test a hypothesis once. You come back and you think about different ways to test it. You're not going to do it, but you need to at least think about other ways you could test your hypothesis. And if you want, you'll get extra credit. So if you come up with one way to do it and write about it, that's what you're required to do, but you could write others and get extra credit. Any questions about that concept? Right. Next is, this part's really, really easy. The next section is figures and tables. You already have the table, right? The table is from the lab worksheet. If you want to, copy it and paste it. Just make sure you use the correct name. So for example, if you do experiment 5, on the lab worksheet, it's going to say table 5. But for you and your lab report, it's not table 5, right? It's the first and only table. Therefore, it should say table 1, right? So make sure you do that. Pretty simple, right? Copy paste. Then, as usual, like you've been trained to do this, you're going to make a graph, right? Except the only difference this time is you need to use a computer program to make it. This time you don't want to do it by hand. You can do it by hand for the lab itself, like as usual, but for the lab report, you're going to use some sort of computer program to actually make a graph, and I can help you with that. Yeah, and usually I want you to figure this out on your own, but I'm going to go ahead and tell you now. For these graphs, since you're going to have like data, right? You're going to have continuous data starting from 5 minutes going to 45 minutes. Therefore, a line graph is appropriate, right? So if you did the experiment, where it's like, does light intensity affect the rate of photosynthesis? Again, just to remind you, not that you need to memorize that, but there was 4 cuvettes, right? So you have a line for the cuvette that was closest to the light, and then a line for the cuvette that was medium distance. Then you'll have a line for the cuvette that was farthest from the light. Then you'll have a line for the cuvette that was in the dark, right? So I recommend, again, a line graph. Now I'll come back to that concept here in a second. But also, again, you're going to want to label it figure 1. That's the part that I haven't been grading you guys on, even though I told you on lab 1 you should say that. So I have been grading you on, does it have a proper title? But so if I haven't been grading you on this, it technically should say figure 1 and then the title of the graph. So this is the one time this semester where you will lose points if you don't start with figure 1 and then describe the data in the graph. Again, I can help you with that. Yep. As always, your graph should make enough sense to where anybody who looks at that graph, even without even reading the lab report, should know what it means. And of course, you're going to include units. So for example, in the last lab, a lot of people correctly put time, but in parentheses, they didn't put minutes. So time, what does that mean? Seconds, minutes, hours, days, weeks, years, right? So make sure you include your units. And of course, for your y-axis, there are no units. It's just pH. So yes, that's what's required of you. Now, granted, you could also, for extra credit, do more graphs, right? So this shows the change in time for each one of the cuvettes. You could then just do also a bar graph using the same example, like this one and the closest to the light or farthest from the light changed this much. The one closer to the light changed this much total. The one close, so on and so forth, right? You could you could use a bar graph to only graph the final results, like the total change, right? And you could do that for extra credit. But for this, you need a line graph showing the change over every 5 minutes. Yeah. So any questions about figures and tables? Okay. Actually, this one's the easiest. Next is literature cited. This is pretty easy. It's a lot like you're in the, oh, no, I don't say that. I don't care what format you use. I don't care. I don't have this section in here like a English professor would. I have this section in here because I need to make sure your information is correct. So like I said earlier in the introduction, if you did the experiment about temperature, you're going to need to write a couple things then about how temperature affects chemical reactions and how temperature affects enzymes, right? And when you do that, I just need to know what your source is. Actually, honestly, this needs to be Well, maybe, I don't know. If all the information you found, if you found enough information in the lab manual or the lab worksheet, you can just use that. But most likely you're going to at least look at your textbook, if not some other source. And that's it. Just make sure I can read your source, right? So if it's some web page, then give me a link, a working link to that exact web page. If it was the textbook, well, I mean, it's an online textbook. So yeah, give me the exact link to the exact page where you got that information. But that's it. Again, I don't care about the format, the APA, MLA. For me, this isn't a formality. For me, this is me checking to make sure you're correct. Because if you write something that's incorrect, but then I go and check your source and it says that incorrect thing, you're not going to lose points for it. It's not your fault that the source was incorrect. So are there any questions about the literature cited section? All right. Once again, very quickly, because then we'll be done. And I'll have to give you your, almost an hour early. Anyway, really quick to go. Come on. Just want to show you again. Good grief. I lost it. Oh, man, I X out of that, huh? Anyway, this lab worksheet has everything you need to know. Everything I just told you is right there in the lab worksheet. So like I said earlier, if you forget everything else I just told you, it's all right here. This tells you exactly what's needed in your lab report. This tells you, or excuse me, your abstract. This tells you exactly what's needed in your introduction, exactly what's needed in your materials and methods, so on and so forth. It's all right there. So you're going to use this to write your lab report below this line, and that's it. Let's see. Last word for attendance. Yeah, this one will require looking at the screen instead of me saying anything. And I'm kind of giving you hints here, but how many total points is the lab? No, that's confusing. Never mind. Never forget it. The last word for attendance. Then I'm not going to confuse things. For the last word for attendance, as usual, send me one sentence where you ask some question about the materials I presented. And again, I'll remind you, this should be in by 10 minutes from now. So you have until 11:20 to send me those words. Don't send the words to your buddies because I will get a spreadsheet that shows me who was here, when they logged in and all that. So you're just wasting your time and theirs if you do that. As a matter of fact, since I've now warned you about it, I will now consider that cheating. So if they didn't log in until halfway we were through and they give me words, I'm going to give them 0 credit because I will have known they cheated. So does anybody have any questions? All right. In that case, we are done with lab. Hopefully I will see you guys in person on Friday. I'm going to try to stay online if anybody needs me.